Hello everyone. In our last classes, we were discussing about our function. So we stopped with when we were given the equation for the function, and using that equation, we could find out that what are the pairs that we can form in the function. And in those pairs, we used to find out the domain and the range. So domain was what? The values of x, all the x coordinates, and range was values of all the y coordinates, right? But that technique could only be used if I have the function f in the form of pairs. That f has 2, 3, 5, 4, 7, 6. Then I can write that domain are all the x coordinates, range is all the y coordinates. But now we are going to move to the section where we won't be given f, the function, as pairs. We would be given function as an equation, only equation. See, earlier the questions were of these format. X2, don't write, and x belongs to 0, 1, 2, 6. So my domain will be what? 0, 1, 2. The values of x is what? 0, 1, 2. If I put x equal to 0, I'll get 1. So 1 is the range. If I put x equal to 1, I'll get 3. 3 is also in the range. I put x equal to 2, I'll get 5. 5 is also in the range, right? So I'll have 1, 3 and 5 as my range. Domain 0, 1, 2. I've already given you. Agree? Now what will happen is, instead of giving you the question in this format, I'll say that f of x is 2x plus 1. This is your function. You need to tell me what is domain and what is range. I'll only give you equation, nothing else. So now everything we need to find, that what are the values of x here I can put, what is the answer that I can get. Everything we have to find from here. Now, first, here when we talk about domain and range for the function, what we are allowed to have, the maximum answer, the largest answer that we are allowed to have is all real numbers. That no matter what you put here, it's okay, right? So what is a real number? Everything except two situation. First, denominator should not be 0. And second, even root should not be negative, right? Inside the root over, we should not have a negative number. Rest everything is a real number. So for us, the largest set would be real number. And then what we will do is, from that we will find out what are the values I'm allowed to use that will come under domain, or whatever is not allowed to use, throw them away, right? So now in this case, in case of in equations, please write, in equations, domain is set of real values of x allowed to be put in the given function. Allowed to be put in the given function. The range will be set of real values of y or fx. Y and fx were same things. In the last class, I told you yes or no. Online. Are you aware that y and fx are same?
Yes, ma'am.
Yes,
Yes, ma'am.
Set of real values of y or fx that we get as results from the function. So same pattern. When you do that thing for x, it becomes a domain. When you go to the same procedure for y, it will be known as the range. If I say x is 0, 1, 2, so 0, 1, 2 will come under range, domain. If I say y is 0, 1, 2, then 0, 1, 2 will come under range. So values of x comes under domain, values of y will come under range. So what we will do here is, we'll remember two things. I'm not allowed to have two things. First, my denominator should not be 0. And second, inside the root over, I should not have a negative sign. I have to remember these two things. Rest, I'm okay with everything. I can have 0 in the numerator. I can have root 2. I can have root 5. I can't have root minus 2. Right? I can have 1 by root 2. I'm okay with it. I can't have 1 by root over minus 2. I can't have 1 by 0. So I need to make sure that I should not have 0 in the denominator, and I should not have a negative number within the root. If these two things are checked, then I'm okay with everything else. So you can take all the values, right? So first, when we are finding domain, we'll start with domain. That means I'm going to consider what are the values of x that I'm allowed to put in the equation. So we have two varieties of question. First variety. If it is a fraction, numerator upon denominator, then what is not allowed? Denominator should not be 0. And this in return will give me, say, values A and B. For example, see. First understand. X minus 1, x minus 2. It's a fraction. So what will not be allowed?
Equal to 0.
X minus 2 should not be 0.
Is
In that case, what should not be the value of x? 2.
x should
Because if
not.
I take x equal to 2, then my denominator will become what? 0. If I take x equal to 1, my numerator becomes 0. I have no problem with that. I have a problem with my denominator being 0. So if I take x equal to 2, my denominator will become 0. I'm not okay with it. So what should not I take? I should not take x equal to 2. Do I have a problem with any other number? 3, 4. If I take x equal to 1, no, I don't have a problem. I can have a negative number in the denominator. I can have a fraction in the denominator. I can't have 0 in the denominator. So the only number that I have a problem is 2. Rest all real numbers are allowed. 1, 5, root 2, root 7, 1 by 2. Everything is allowed. Only one number is not allowed, which is 2. So I have all real numbers in my domain. What is domain? The values of x that I can substitute here in this equation. The values of x that I can put here in this equation. So I'm allowed to have everything except x equal to 2. So domain means what are the values of x that we can put in this particular given equation. So I'm allowed to put everything, all values of x, all real values of x except x equal to 2. So here what I'll do is my domain will be all real numbers. I can take everyone except which one? 2. So R is set of real number. So 2 cannot be a number. I can't subtract a number and a set. Did we ever study A minus 2? No. We studied A minus B. Difference of 2 set. So 2 also has to be written in set format. So what we do is we find out what are the numbers that are giving you trouble. So here it was 2. So from the real number, I removed that. So here, for example, if A and B are giving me a trouble, then my domain would be all real numbers except A and B. Remove only these two numbers, rest everything is allowed. Understood? Online understood?
Yes, ma'am.
Yes. If I would have given you a question, function is 3x minus 5. What would be the domain? What would be the domain? Is there a denominator?
No,
No.
ma'am.
So denominator can't be 0. Is there a root over?
No, ma'am.
No. So the only two things that I can have a problem with are not even here. So will I have a now new third problem? No. I have only two problems. Denominator, which is not there. Then root over, which is not there. So my both the problems are not here. That means I have problem with no one. So what are the values of x that I can put here? Any value, whatever you wish. So what is that? Real number. So in this case, my domain would be all real numbers. I can put anything here. Domain will be all real numbers. Everything is allowed here. Is it understood?
Yes, ma'am.
If I give you the function 1 by x, what will be the domain? Answer, guys.
X not equal to 0.
The denominator should not be equal to 0. So I'm not allowed to have x equal to 0, right? So domain will be all real numbers except 0. All real numbers except 0. If I give you function, this. See, in this equation, is simplification possible? Yes. The denominator can be used. We can use in the denominator a square minus b square. So I can have x plus 2x minus 2 and cancel. But I can't. I won't. If I'm finding domain, I need to take the function as it is, in whichever state or form they have presented it. Right? No cancellations, no simplifications, nothing, right? Because it's the original question. So while finding domain, no simplifications are allowed. But while finding range, range is answer now. So in the answer, do we ever write 2 by 12? No, we write 1 by 6. So while writing the answer, while writing range, I will always have to simplify. But while writing domain, you need to take the equation as it is. You can't simplify. So right now I'm allowed to simplify. I can simplify, but I'm not allowed, right? So in domain, we use the function as it is, right? If the same question would have come for range, I would have simplified. Understood? So in this case, domain. So what should I proceed? How should I proceed? What should I do?
X square minus 4 not equal to 0.
Right now. So this is x plus 2, x minus 2. So x plus 2 should not be 0. That means x should not be minus 2. X minus 2 should not be 0. So x should not be 2. So my domain will be all real numbers except 2 and minus 2. Everything is allowed, only these two numbers are not allowed. Yes, guys, is it okay?
Yes, ma'am. Yes, ma'am.
Question, function x square plus 2x plus 1, x square minus 8x plus 12.
Ma'am, domain should be all real numbers except 2 and 6.
Okay, rest of you. So what should not be the case? X square minus 8x plus 12 should not be 0. Midterm 6 and 2. So x should not be 6 and 2. X should not be 6 and 2, right? So my domain will be all real numbers except 6 and all real numbers except 6 and 2. Any problem?
Ma'am.
Done?
Yes, ma'am.
Done? Question, function function x plus 7, x square minus 8x plus 4. Done? So what will we do? X square minus 8x plus 4 not equal to 0. Can we do a midterm here? Is it possible to do midterm here?
No, ma'am.
No, ma'am.
So what we will use?
B
X
square
should
minus.
not be equal to minus b plus minus b square minus 4ac upon 2a. The quadratic formula.
Yes, ma'am.
So x should not be equal to 8 plus minus b square 64 minus 4 into 1 into 4 upon 2 into 1. So x should not be equal to, please solve,
I'm 48.
8 plus minus 48 upon 2. X should not be equal to 8. 4 root 3. I can cancel 2 taking common. Should not be equal to 4 plus minus 2 root 3. X should not be equal to 4 plus minus 2 root 3. Yes or no? So my
Yes.
domain, sometimes it is also written as D of F. Domain of F. Domain of F. So this would be all real numbers except 4 plus minus 2 root 3. 4 plus minus 2 root 3. Yes or no?
Yes, ma'am.
Any problem?
No, ma'am.
No, ma'am. Understood?
Yes, ma'am.
Yes, ma'am. Done?
Yes, ma'am.
Understood, everybody? Now, the second is, okay, what will happen here? If I tell you function is x square upon 1 plus x square.
All real numbers except minus 1.
Now, 1 plus x square. Can 1 plus x square ever give you 0? For it to happen, x squared should be equal to -1. Is it possible?
No, ma'am.
No.
No.
So 1 plus x squared, no matter what you take x, it can never give you your denominator 0. Root 2 is not there. So the only problem that I can have is denominator being 0, and that cannot happen. So am I having problem with any value of x? No. My domain will be all real numbers. My domain will be all real numbers. I have problem with none. I have problem with none. Understood? Understood?
Ma'am.
Now, the second variety is root over. So this expression which is present inside the root over should always be greater than or equal to 0. Always. Yes? I'm okay with 0. Root 0 is 0. That's okay. But I'm having a problem with root -1, root minus 0.5. So whatever term is written inside the root over, it should not be negative. Right? So for example, in this case, we will need intervals. What was interval in set? Open interval, closed interval, right? So here again, we have all real numbers as an option. Let's see what we are allowed. So if my function is under root x minus 2, so x minus 2 should be greater than or equal to 0. Yes or no? Whatever is the term inside the root over, that should be greater than and equal to 0. Is it understood?
Ma'am.
Yes, ma'am.
That means x should be greater than and equal to 2. X should be greater than and equal to 2. Yes?
Yes, ma'am.
So in this case, what would be my domain? I have the entire real number, right? Last time they gave me x not equal to this. Don't take this. So I wrote what? All real numbers except this. I have a problem with this number. Right now, what am I saying is you should take all values that are greater than equal to 2. So that is my answer. So if this is 2, I'm allowed to have 2 and more. More is right side. I'm allowed to have this portion. So my answer would be 2 to infinity. Am I allowed to take 2? Yes. So square bracket, because if I put 2, I get 0 in the numerator. That's okay. Infinity. Infinity is always round. No, infinity is always round, no matter which portion you're. Infinity will always be round. Clear?
Yes, ma'am.
Everybody clear?
Yes, ma'am.
Yes.
Now, if the same question would have been 1 upon root x minus 2. So here there are two problems. The denominator should not be 0. The root over, it should be positive. That means in this case, I want x minus 2 greater than 0. I don't even want 0. Yes or no?
Ma'am.
Is it understood?
Yes,
So
ma'am.
this means x should be more than 2. So my domain will be which case, Bhumika?
Ma'am, last.
Why will I write r minus 1? Even 0, I have a problem. Even if I take x equal to 0, I have a problem. So I have 1.9, I have a problem. 1.8, I have a problem. I have problem with everything smaller than 2. I don't have a problem with 1 or 2 number that I can remove them. That's why I wrote that take numbers from 2 or more.
Okay,
In
ma'am.
root
Thank you.
over, the answer will always be an interval. Whenever we have fraction, the answer will always look like r minus this. Because I have a problem with 1, 2, somewhere around that. But in interval, I have a problem with a lot of numbers. So instead of removing them, I say that count this. Only take this portion. Yes?
Yes, ma'am.
So here the domain will be 2 to infinity. Because I'm not allowed to take 2. But I'm allowed to take 2.1. I'm allowed to take 2.2. I'm allowed to take 2.5. So round. So round open interval means any number between this. From between 2 and infinity. Don't take. If I would have written square bracket, that means you take 2 also. Clear?
Yes, ma'am.
Question. Function is under root x minus 5. Answer.
A domain is closed bracket 5 to infinity.
Very good. So x minus 5 greater than equal to 0. X greater than and equal to 5. So domain will be 5 to infinity. I'm allowed to take 5 because if I take 5, I'm getting 0 in the numerator. That's I'm okay with it. Done?
Yes, ma'am.
Now, in case I have a quadratic equation inside, say here, x square minus 4. This how we will understand. X square minus 4 greater than equal to 0. Huh? In this case, factorize. I can write this as x plus 2, x minus 2. Any problem till here?
No,
No,
ma'am.
None.
Now, suppose instead of more than, if I only had equal to, then what would have been the answer of x? Plus 2 and minus 2.
+2 -2.
So what I'll do is, in the number line, I will plot those values. First comes minus 2, then comes plus 2. Did you understand this portion? In your mind, imagine that rather than more than, I have equality. Then I'm going to get 2 and minus 2 and 2. I plotted them. Which does what? It divides my entire number line into 3 parts. Minus infinity to minus 2, minus 2 till plus 2, and from plus 2 to infinity. So what we will do is, we will take a number from any one of the position, any one of the portion, any 3 of the portion. I'm going to take a number from any one portion. Say 0. 0 will be where? Take it. So what I'll do is, at x equal to 0, I will see what will be my function. In your original function, put x equal to 0. What will I get? Am I allowed to have this answer? Am I allowed to have this answer?
Um,
No.
No, ma'am.
So this can't be your answer. This means since 0 is not my answer, so whichever portion 0 belongs in, the entire portion cannot be my answer. So from minus 2 to plus 2, that's not your answer. Is it understood? And this is always alternate. For example, if I would have taken a number smaller than minus 2, say minus 3, put minus 3. Minus 3 square is 9. 9 minus 4, 5, root 5. Positive number. I'm okay. Take a number more than 2. Again 3. 3 square is 9. 9 minus 4 is 5. I'm okay with it. So what we do is we test for only one portion. If the middle one is no, it is always alternate. So before yes, after yes. So I'm allowed to have these two as my answer, but I'm not allowed to have the middle one as my answer. So here my answer, my domain would be from minus infinity to minus 2, union 2 to infinity. Either you take a number from the first portion or you take a number from the third portion. Now, am I allowed to take 2? If I take 2, what happens? Root over 0, numerator, I'm okay with it. So take it. Same goes with minus 2. I'm okay with it. Take it. Yes?
yes, ma'am.
Yes, ma'am.
Clear?
Yes, ma'am.
Suppose my question is function root over 16 minus x square. Try. First, 16 minus x square should be more than and equal to 0. So this is 4 plus x, 4 minus x, greater than equal to 0. I'll get two answers. What are those? What are those?
4 and minus
minus
4.
4.
Minus.
4 minus 4.
Minus 4 and plus 4. Now, what will happen? Now, let's take a number. Why? Please. Let's take 0. Here is 0. Put it in the function. Under root 16. Am I okay with it?
Yes.
Yes. If I would have taken a number smaller than minus 4, minus 5, 16 minus 25, I would have got a negative number. So even though the middle one is yes, so before one no, after one no. It's always alternate. So here my domain will be minus 4 to plus 4. Can you tell me the bracket? Closed means take the number. Round means don't take the number. So can I take 4? Yes, because if I take
Yes.
4, I get 0 in the numerator. So I'm okay with it. Yes or no?
Yes, ma'am.
Everybody clear?
Yes, ma'am.
Yes.
Yes,
Yes,
ma'am.
ma'am.
Question. Try. Nine. First, 9 minus x square greater than 0. In this case, I'm not even allowed to have 0. Why? Because it is sitting in the denominator. So this would be 3 plus x, 3 minus x. I'll have two answers, minus 3 and plus 3. Yes? If I take 0 at x equals 0, I'll get the function to be 1 upon root over 9. I'm okay with it? So yes, no, no. So the domain would be minus 3 to 3. Which bracket?
Small bracket.
Round bracket. Because if I take 3, the denominator becomes 0, which is wrong. Yes?
Yes,
Yes,
ma'am.
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 Everybody clear?
Yes, ma'am.
All of you clear, guys?
Yes, ma'am.
Question. Under root x plus 3. Under root x squared plus 3x plus 2. Try. First one, what should we do? X plus 3 greater than 0. X would be greater than minus 3. So the domain would be wrong. Yeah, it will be from minus 3 to infinity. Both round, because if I take, sorry, my fault. I can take minus 3 because I'm going to get root 3, 0. Yes?
Yes, ma'am.
Here, it will be root over x plus 1, x plus 2. So I want x plus 1, x plus 2 to be greater than 0. So what are the two numbers? Minus 2, minus 1. So now if I take 0, 0 will be here in the last one. Root over 2. Allow? So yes, no, yes. Clear? So domain minus infinity to minus 2 union minus 1 to plus infinity. Yes? So infinity round. What about 2 and minus 2? Square or round bracket? Guys, am I allowed to take minus 2 and minus 1? Square bracket or round bracket?
Square, ma'am.
Square,
Square.
ma'am.
Because if I take them, I'm getting 0 in the numerator. That's okay. Clear?
Yes, ma'am.
Yes.
All of you clear?
Sure.
Yes. Now, in some cases, there are certain exceptional questions. Matlab, exception in the way of approaching them. Suppose the function is, okay, let's work on this, then we'll come back here. Right. Is it okay till here? Okay, let's
Yes,
start exercise 9.2 then. Okay, first question number 1. Function is 3x squared plus 2x minus 1, x plus 1. F of minus 3 plus 1. So in this function, instead of x, put minus 3 plus 1, minus 3 plus 1. 27 minus 6 plus 1 by minus 2. Answer. Minus 11 plus 1, minus 10. Sorry? Okay, let's change the question. So this is 20 minus 10 plus 1, that is minus 9. Yes?
yes, ma'am.
Question number 2. The function was 3x minus 2. We wanted f of minus 3 plus f of 0 multiplied by f of 7. F of minus 3. 3 into minus 3 plus 2 minus 7. F of 0. 3 into 0 minus 2 minus 2. Into f of 7. 3 into 7 minus 2. 19. Final answer.
Minus 49.
Question number 3. Function is x cube minus 1. In the question, it is given that f of x is 215. So x cube will be 216. This is 6 cube. So x will be equal to 6. Done? Next, question number 5. Number 1. We only need to find domain, and while finding domain, we don't simplify. So this is fraction. So what should I do? The denominator should not be 0. So x should not be minus 2. So domain will be all real numbers except minus 2. Done?
Yes, ma'am.
Second one, function x upon x square plus 3x plus 2. This is x plus 1, x plus 2. So again, the denominator should not be 0. X not equal to minus 1, minus 2. So domain, all real numbers except minus 1 and minus 2. Does it match? Third, function is x cubed minus x plus 3, x squared minus 1. So again, the denominator should not be 0. X plus 1, x minus 1 should not be 0. So x should not be 1 and minus 1. So the domain will be all real numbers except 1 and minus 1. Is it clear?
Yes, ma'am.
Any doubt?
No, ma'am.
Okay, that's it for today.